Yes.
I'm just waiting for it to show up on my phone. I wondered it. Maybe I need to reload this. Oh, here we go.
Yeah, we are live streaming.
It just started appearing now. Oh, it looks like it's oh, there we go. I thought it was frozen, but it just so I wasn't moving my head very much while I was checking it out earlier. Looks to me like it might be around 20 to 30 seconds behind the actual streaming. I mean, at the point where it shows up on my phone.
Mm-hmm.
Aha, the Beehive terminals were dual-use devices. They were sold in the medical industry as well, to be non-interfering.
Mm-hmm. So, Federico, were you thinking of doing a Tempest talk at scale? Is that what we were talking about earlier?
Well, I don't think that that we can do a real Tempest talk because it's classified, but we can talk about something that's related. Spiritual is similar to Tempest, so that's the idea.
It should involve teacups.
I'm sorry?
I said if you're going to do a Tempest adjacent talk, it should involve teacups in some way.
Okay. Yes, I see. I see the point. I think scale is moved back to March schedule, so if I decide to commit to developing this new talk, that would be when I need to do it by. And basically, I can do a preview in January or February, whatever you would like.
Well, we already have someone signed to January, so February's next opening.
I'll let you know when I send in the abstract. I'll let you know.
Okay, sounds good. You think it makes sense to have a talk on Fedora 37 now that it's been released?
We could do that. I haven't installed it yet.
I can't confirm or deny. I pretty much use Mac OS most of the time. So.
Yeah, it was just released.
Here.
Yeah, I didn't want to install it right before the meeting.
Mm-hmm.
Didn't. I'll probably install it tomorrow sometime.
That sounds wise.
The last distro that I tried was 2204. I forget what the nickname is. The distro itself was all right. I'm not sure why it was performing so poorly on the laptop that I chose for running the test. It was an old Sputnik, a few years dated, but it was still a 4-core machine. It was somewhat sluggish. I didn't like that. I liked everything else. I think the problem is that couldn't install in that machine without. It has one of these hybrid SSD devices that are part solid state and part not, and you needed to decouple this functionality and basically not use the drive the way Intel intended, and that kills the performance of the machine. So I chose the wrong machine. On.
The one I just installed on says, if there's an SSD installed, don't try to format it. It's just there for caching as a hybrid for whatever's in the SATA slot. But I don't think my ThinkPad has the M2 at all. It's just one of many SKUs that fall under the same general model that has it. I did boot that under 2204 off a Ventoy thumb drive multi-boot, but I installed 2004 and have rolled most of my other systems forward to 2004 now. Desktop will follow shortly.
So did it work well, or what was the...
It seemed to be okay. I just tend to run one LTS behind. I was a little startled at how many LTSs behind one of the laptops was.
I have a sort of a library of old laptops that I pick up at MIT Flea or eBay for about $100 each whenever I have the opportunity. So
exactly.
I basically have all versions of Ubuntu since 14. Well, I have a few before 14.04, but I have all versions of Ubuntu since 14.04 on different laptops, and I just pull it from the library whenever I want to check something. Mostly because for writing purposes, it's convenient to have access to a specific system at a moment's notice. So.
Yeah, I've got some older laptops. I've got one of these, the ThinkPad X, that has the swivel monitor and the stylus docking port. That's 32-bit, so it's probably on 14 or 16. There may have been an Ubuntu 32-bit at 18 or 20, but that's when 32 bits cut off.
I actually ran into that. I think at the beginning of the pandemic, I was restoring an Asus One, these really tiny laptops with 11-inch screens. I guess they call them netbooks or something like that. 11-inch screen, 2 gigs of RAM, cores, low power consumption, but very underpowered. And I found one of these that was in really good condition. So I thought, hey, let's make a little terminal station where basically you're just going to SSH from this into whatever you need to connect to. And the biggest challenge was that this was obviously a not fully 64-bit system. So I needed to find a reasonably recent distribution with 32-bit builds, and it's getting hard. I think I don't remember if it was Mint or one of the Ubuntu derivatives, not Ubuntu proper, that eventually I settled on, and it was like an 1804 of this branch distribution that was still available in 32 bits.
Yeah, Ubuntu 1804 is what I've got for my Ventoy for a 32-bit 386.
Okay, I guess we can start. Federico, I couldn't hear you a second ago. Can you hear me?
I can hear you. Can you hear me?
Yep. Yeah, I hear both of you.
Can anybody hear me?
Yes.
Yeah, we can.
I can.
Jabber, can you hear me?
Yes, I hear you.
So, okay, let's wait for Jerry to kick us off.
Hey, Jerry, you want to introduce Federico so we can have that bit at the beginning of the video on YouTube? Now I'm wondering if Jerry can hear me.
I suspect from what he said he can't. Which is why I typed in the chat at him, and he doesn't seem to be reading the chat.
Does Jitsi alert you if you give a private message? I know it colors it in the chat, but does it actually make something obvious to alert you?
I could draw a sign that says, Jerry, we can't hear you, or you can't hear us. Hold it up for the camera.
I guess that's worth a try. Looks like he might have stepped away, though.
He frankly looks frozen.
He does. You were not kidding. While we wait,
We do have a screen.
Bill, this is the book.
Spy in Moscow Institution.
Yeah, I'm pretty sure that's the one that's, well, one of many that's sitting in the TBR pile.
The read buffer.
With forward by Michael Hayden. Ooh.
Right, they had an actual director of the No Such Agency do the forward. And then he was some kind of CTO of research or something like that.
It looks like Jerry's connected twice now.
if I remember the foreword correctly, the preface correctly, Hayden recruited Hazeltine his after his time at Walt Disney.
There's another book by the wife of the married team that were CIA's disguise specialists, and they did things that were very much like what Mission Impossible was doing, but in real life and on tighter time scales.
Hmm.
On the talk show circuit now.
Okay, is anybody hearing me?
Yeah,
Oh
Harry,
yes.
Yes.
Oh, good. Yeah, it was weird. My earphones disconnected and then went to settings and it locked everything up.
So this actually is the ASUS that we were discussing. So it turned out that was Ubuntu Mate 1804 that I used in the end. And it worked fine. You can actually use this as a reasonable terminal. You have to like small keywords, which I'm fine with. And yeah, it restored very nicely. I had to use polishing compound as if I was buffing a car to get the surfaces to shine again. It's a very shiny device for some reason, but it wasn't in such a bad shape that that this was particularly difficult. And at the time, there was um, a friend of mine, Stuart Langridge, also former Canonical, that was working on a rolling distribution of Ubuntu. So that was also an interesting idea to try to have a laptop with a rolling distro instead of a checkpointed distro like all others. But I haven't gotten around to that yet.
Oh, Federico, is this supposed to be part of your talk? Because I was hoping to get a little gap at the beginning that I could easily find when I'm editing the YouTube, so I know where to cut it.
Mm-hmm.
So, you think we do that now? I'll just maybe put up something visually so I can see easily, and I'll leave it running for maybe 20 seconds.
I'll just full screen this.
Okay.
You can see the various screen caps of this thing.
Okay.
The battery kind of sticks out from the back of this device, so it has a strange battery kind of handle. But otherwise, it's fairly unremarkable. It's nothing too strange. And maybe it is remarkable because it was one of the few netbooks that it's still worth using now. Most of them were not even worth using back when they were new. Okay, so shall we? Let's go for really older hardware now.
Okay.
So I thought about how to do this. I thought about actually wearing this camera that I have that mounts like eyeglasses so that I can walk you around the hardware. But actually seeing the hardware itself that way would get old pretty quickly. And I figured out that I had most of what I did documented already in my first use of Twitter threads. So I'm going to actually use much maligned Twitter as my presentation software for this one. Mostly because the pictures are all preloaded there and the narration is already in place. So let's see what the first system is. I collected a bunch of threads here as starting points. I guess a little bit of history is warranted. So I got into retrocomputing during the pandemic, I guess, as a way to do something while locked, then shut in at home. And I've rebuilt quite a bunch of things now, a few IBMs, and then after that I branched into systems that I actually never used, like Commodore 64. I had never used before, so it was an interesting learning experience. Um, um, Early Macintosh System 6 and System 7 machines. I had used some of those, like a Mac 2 SE, but I had them as Unix systems. I had loaded NetBSD on them when I was in college, so I didn't have any System 7 experience, so that was another learning curve. I started rebuilding an Atari laptop. It was the most challenging one so far, and actually it's stored here because the project was never completed. A few things like that. So let's look at some of those. So this one is actually harbinger of things to come. This is before the pandemic started. I found this PS Model 70 on eBay, and it just looked too good not to buy. um, LCD screen, bright red, looks like a device to start a nuclear war or something, doomsday type device. Here on the right, the floppy disk that pops out is actually kind of cool, and that floppy works perfectly. It's interesting when you get older and older machines how much trouble floppy disks are, um, even more so than hard drives, surprisingly. So that was a good start. It is a 386, so you could actually run Windows here. Not that I would want to. And there wasn't much restoration work to be done here. The machine was in good condition. Maybe I tweaked the configuration a little bit, but it was a fresh install of DOS 6 from whoever was selling it. And we actually can see that Bill already commented on that back in 2017 when I got this. The cool thing of this is that the keyboard is actually a full-size IBM keyboard, and it's maybe not as clicky as the original IBM PC one, but it's pretty close, so it makes quite a bit of noise when you type on it. And yeah, in this screenshot you can see Windows 3 running. And I think it's cooler as a DOS machine, but there you go. This was before Twitter threads became hip, so it's not as connected as what I'm going to show next. But then the first of the recent stream of projects. So if I remember the ordering correctly, this is another 386. Let's see. The laptop was a 386 SX, to be precise, which for those of you who don't remember, it means that it's a 386 in the pinout of a 286 with the memory bus of a 286, so that it was substantially easier to retrofit in all their machines. This one is also a 386 SX, if I remember. And the idea is that it's a pizza box format PC. It's made by NCR in Germany, actually. This was also a very nice condition find. And one floppy disk, one hard drive, not particularly noisy, which I kind of like. I decided that I would try to build this into a sort of a universal DOS gaming machine. So I tried to build into it as much compatibility as humanly possible. So the first thing was putting in a Etseng Labs ET400 VGA. This used to be the most compatible VGA of the early 90s. In the pre-acceleration era, this was the card to have. There were a couple of fancier things that you could get, but this one was the fancy common thing, and it generally supported almost all games that could use VGA or that could use these VGA non-standard modes. So little history lesson. I guess we'll have a lot of those. Video card format like VGA, GA, CGA. CGA had 4 colors. EGA had 16 colors, or shades of gray, depending on what your monitor was. VGA had 256 colors. However, people discovered that they could hack the registers of VGA cards and create all manner of non-standard modes in terms of both resolutions and, in some cases, color densities. The VGA standard was what IBM defined, but then there were these third-party manufacturers like Sang Labs being the most visible one that would make these cards that would start as VGA, but then they would go way farther. And so with the Sang Labs card, if you were compatible with the card specifically, you could have higher resolutions than things like 640 by 480. And you could have, if I remember correctly, on this one, up to 65,000 colors, as opposed to the maximum of 256 that VGA proper supported. So this one was convenient, not because most games would go that far, but because almost everyone who would program video chipsets knew how to hack the Sang Labs registers. So for things like demos, this one was a very compatible card to play things against. It was Sang Labs at the beginning, then various S2 or S3, I can't remember, accelerated cards afterwards, and then the Voodoo Banshee towards the end of the decade, the 3DFX accelerated cards. Those were the 3 most compatible things. So here we're really at the beginning of the decade. This is a 1989 machine. So we're trying to go for compatibility with games of the late 80s range to basically 1992, 1993. Doom 2, Doom 1, frankly, is where this machine is going to be too underpowered to perform. It's still going to run, but it's not going to be a pleasant experience. The other thing is that early IBM PCs, or really for the first 15 years, IBM PCs essentially had no sound other than the chirpy speaker. So an audio card was a very big extension for playing games. Here underneath, you can see that there is a fairly modern sound blaster. This one is a CT2950, which is something that, in theory, you can configure manually using DOS utilities in a non-plug-and-play system. So it's a plug-and-play card. It expects plug-and-play operating system, which obviously DOS is not. But there were utilities that were made so that you could manually its onboard configuration had no jumpers, so you had to do it in software so that you could operate it without a plug-and-play OS. And I went through all that, but then it turned out that it wasn't sufficiently compatible, that we really needed to have a Sound Blaster 1.2, the common first version of the Sound Blaster, for the maximum compatibility project. There is more to that story, but we'll get to it when we get to the cards. So it booted pretty well. I maxed out the memory eventually, but this is DOS, so it sees the 640 kilobytes. That is the maximum that DOS would support. This machine, I believe, has 8 megabytes if extended memory mode can be used, which on PCs of the era was usually done with Windows, but there were these things called DOS extenders DOS 4 GW was the most common one for games, and that would basically start from DOS and put the CPU in 386 mode and access the rest of the memory without killing DOS. So that became the standard for games in the latter part of the decade because more memory was essential. Windows took a very long time to become friendly to games. It was too unreliable latency-wise. The latency variance was crazy. So even though 3.1 really had explosive growth whenever it came out, I think by my memory it was 1993, people really weren't playing games in Windows until DirectX and the standardization of drivers that Windows brought towards the end of the decade. Maybe with Windows 98, which actually had a very long life, way beyond 1998, as a gaming platform, because it was fairly lightweight and slowed down the system, and you could have reasonable drivers that didn't have latency problems. This has the standard PS2 keyboard that IBM introduced for the PS2 and then became fairly common for all PCs, replacing the bigger similar connector of the XT80 PC series of the 80s. Standard 9 pin serial that anybody young will have no idea what it is, except if they are embedded engineers. And then there is apparently a 25-pin serial there on the right for variety. I think this board parallel. Let me see what we have. This board should also have a parallel. This is not in thread. Well, let's find it. This board also has space, and we will see very soon what I did with it. So this was an interesting project because it pretty much used every single capability that the machine had to the maximum, and then I had to stop because there really wasn't any more way to stretch it any further. We put as much memory as it was humanly possible right away from the start. Then the Tsang ET400 that we were discussing before, that global floppy disk celebrity Foon commented that will definitely pass Commander, which is correct. The Tsang Labs was a good fit and didn't need to be replaced. The hard drive, which started being a Connor, turned out to be a bad drive. So I replaced it with something similar. Interesting problems there. The BIOS for this machine only supported 20 or so models of hard drives. So the challenge was finding a still working hard drive that had the same head and cylinder configuration, which at the time you had to enter in the BIOS how many heads, how many cylinders, how many platters your drive had, so that the system would know how to drive the hard drive. Though it sounds ridiculous today, but that's the way it was. So I found one of those. In most of the BIOS of the age, the configuration was free format. You could enter these numbers. But in an attempt at making things easy, NCR basically pre-loaded configurations in these machines, and there were only these 20 configurations. So I had to find a hard drive that matched that, and I believe it was Martin at Microsoft, an old colleague of mine at Novell, who sent me basically a list of settings that I could use. That helped quite a bit. And eventually I found a drive on eBay from a vendor called Our Drives Work that would actually work. So we got the hard drive and the video and the memory. That's a start. We thought that we had the sound because the Sound Blaster was working, but then when actually trying to do things with that card that was too modern, and it would lock up. So we had to retrofit that card with something older. The funny thing is that the old original Sound Blasters, not too many of them were made, and therefore the result is they're pretty expensive these days. Sound Blaster 1.2 is going to be 2 or 3. You can even find one. So one of the popular hardware hackers on Twitter, I believe it's I think it's Eric Schlapfer, but I may be wrong. Has designed a replacement that's called Sound Barker, which is a 1-to-1 compatible replacement for the Sound Blaster, same chips but manufactured now, and obviously it's a lot cheaper than sourcing an original.
But
in
it
many
doesn't have Germany.
in many cases with these old boards, there is also capacitor decay issues, but not with Sound Blasters as far as I've seen. Bill is commenting about West Germany. That's right. This is an interesting thing. One thing that you do when you're restoring an old computer is that you take out the CMOS cache battery, because it's almost certain to leak at some point, or hopefully it hasn't leaked yet. So if you buy an old system, the first thing to check is for battery acid on the board. If it has leaked, it should be a lot cheaper than if it hasn't. So so far I haven't bought a system that had been seriously damaged by battery acid, but I'd like to continue the trend. So the first thing that I do is I go and desolder the battery. For some of these systems, it's actually kind of difficult to find replacements. This one is one of the more uncommon ones. I was not able to find a Sommerfan battery anymore. I don't know if they... actually, I did find out that they do exist, but they don't make batteries in this format, or they don't sell them to the public. Maybe it's an industrial product. But it really dates the system very well. This was before the Berlin Wall fell, and so it's a West German battery. And as far as I could tell, it's still working just fine. It's just that after this many years, you don't want to risk it, so you replace it. I was looking for a similar replacement, but I couldn't find a non-West Germany Sommerfan battery, so I replaced it with an equally colorful. I think it was Western Electric, some other big name of the past that I found. So the hard drive replacement that we were discussing, the battery came up because Lars Marovsky, a former colleague at SUSE, was commenting. So I highlighted to him that we found the West Germany battery in there. So this is the new drive, which is not Connor, I think. It looks like Fujitsu. This is thankfully already an IDE system, which is sort of a subset of ATA, or an older version of ATA. No strange 1980s controllers, just IDE. And our drives work vendor on eBay was very helpful in trying to help me find a drive that would match the number of platters, heads, and so on that Martin gave me for the broken Connor drive. So we replaced it in there. You can sort of see in here the new battery. It looks like I didn't settle for the Western Electric in the end. This is a very common brand. I forget the name of current CMOS batteries. They're all purple. So I desoldered the old one and soldered a new one in place. Although the IDE bus could support 2 hard drives. The cables built in here on the center bottom of the battery only have connectors for one, and I liked how neat the system was, so I did not try to expand that with a second drive or anything. There is enough space here. The floppy drive was working just fine, as I was saying, so nothing there. And we got to format C, so we're able to install MS-DOS from floppies onto here without too much drama after these stops. So what happens next? Well, we go through the steps of DOS 6.22 setup, which include Microsoft asking you to mail in your registration card, which unfortunately I don't have. This is abandonware at this point, so it's okay to install. Microsoft has actually, they host a web server that has downloads of all their retired software, so that you can find the binaries if you need them. And I did buy Microsoft MS-DOS 6, 6.2, and 6.2.2 way back then. So even if it wasn't free, I would be covered. I actually remember. Oh yeah, I actually noted it here. I remember that I bought 6.2 and I bought 6 and 6.2 as an upgrade, and because I did mail the registration cards way back then, Microsoft snail mailed me an envelope that included 6.2.2 whenever that came out as a free upgrade. So, and this is a pre-internet way of delivering software upgrades. MS-DOS actually installed with relatively small number of floppies. There are things that will start getting significantly ridiculous later, but with DOS it wasn't too bad. 2 or 3 floppies. Now, I don't have a picture here, but there is obviously a problem. Floppy drive, who's got one today? So I needed to find a way to put MS-DOS on floppy drives so that I could install. So what I did is I found a USB floppy drive that I can plug in, and then using the standard disk utility of the Macintosh, amazingly, you can still image you can still reimage floppy drives and put an image of a FAT16 floppy back on. That was fairly straightforward, no particular problems. So we're getting towards the end of the install. 6.2.2 runs ScanDisk, DOS version, check the health of the disk, which we passed with flying colors, so that's good. So it boots in about 47 seconds, mostly because of how much memory is in there. I was wrong, it's not 8 megabytes, it's whooping 16 megabytes. So the memory check actually takes most of that time. Smart drive. What did Smart Drive do? I don't even remember anymore. I think it was a piece of memory management.
It was a disk cache, so that sectors that had been read or written would stay in memory, because DOS didn't do that.
Right. So actually, I had a funny problem with one floppy drive that I had to retire. So this machine was basically meant to be the gaming machine, compatible with everything between 88 and 93. And then the idea was to get a Pentium 1, or actually a Pentium 2, but find something that's sufficiently compatible with Windows 98, that would be the super fast machine with a 3DFX Banshee and all of that, to be the later part of the decade gaming machine. Turned out that the early part was a lot easier than the latter part. But on the latter part, I had this funny adventure where the floppy drive, I guess it was the cache, and something about floppy drive eject wasn't being registered by DOS. Big difference between IBM PCs and Macs was that Macs or generally Sun machines had soft eject, so you would be able to command the machine to eject things, even on Silicon Graphics machines. With DOS, it was always a button where you physically pushed it out.
There's a one of the lines from the floppy drive indicates whether the disk has been changed, and that was sometimes those sensors would go bad.
There we go. So that was exactly what I ran into. So it was funny. I would put in a floppy, do something, eject that floppy, put in a new one, type dir to list the directory, and I would get the directory of the previous floppy, which is something that I've never seen before. So that floppy drive got retired pretty quickly. So we got to DOS 6.2.2 installed. Nothing too surprising there. This is about a month after the project started, because most of the effort was essentially after hours on Tuesdays kind of idea. So in over 4 weeks of ordering parts and poking at them on Tuesdays, we got to this point. Here there is another shot of the original scan disk, which was actually a DOS 6 feature. I don't think it was in 5. Doing its thing and confirming that our new hard drive is actually working. And an attempt at graphics in ANSI format. So we have that part working. Now, next iteration. Oh, right. In DOS, you cannot scroll back to look at your command history. Here I'm just initializing a new floppy drive to be formatted for IBM versus whatever it came. One thing that gets really frustrating really quickly on DOS, if you're not using modern clones like there is free DOS now, is that you don't get command repeat by pushing arrow up or any kind of history. So you're retyping things a lot.
You can, FYI, you can press F3 to bring the previous command back.
That's what I was going to say. You can read the very last thing, and I think that was also a DOS 5 or DOS 6 feature.
It was in DOS at least since DOS 3. DOS 5 did introduce a TSR called DOS key that would let you recall, like, I think up to 100 whole commands.
I never used that one, I must admit. So yay, one full 1.44 kilobytes. And the notes say here, one of the floppies didn't work the first time around, so we fixed it by formatting it again. And that worked. There was the question of whether I would add a second drive as a solid state drive, because a lot of the old hard drives are unreliable. So the solution is to add a solid state device. And so I thought about it for a while, but I couldn't find a cable that was exactly the right size, and I was being very punctilious about keeping the system looking as great as it looked. So I decided to just stick to one IDE device since it was working fine. It is becoming extremely common to just not have any sort of hard drive, just finding a solid state device that is bus compatible with the original architecture and use that. Many of these devices take SD cards, so potentially you could have different images of the operating system and just swap the SD cards. Of course, SD cards are as reliable as they are, but they're still more reliable than dying hard drives. But I didn't have much of a problem with PCs on that, so I would learn that later. So because there are no SD cards, and because these projects are a huge time investment, I decided that I needed to have a backup strategy early on. So once things work, find a way to have a backup for the configuration, the install, everything. And there are no SD cards here, so that created another project that we're going to see in a minute. Then I decided to decorate it a little bit with a bunch of references from the appropriate 90s sci-fi. So this is a reference from Gibson's Neuromancer. This is one of the they're not called terminals or PCs. They're called something else. DEX, I think. In his so got that sticker, and I think I got a couple of others on the other sides. So we were talking about the audio cards earlier. So after I tried with the compatible plug and play, but not necessarily card, I went and restudied the older cards. I actually was an early adopter of Sound Blaster cards. I had the first 1.2, the original Sound Blaster, the 1.2. I had one, I don't remember if I had the 1.5, but I had the first Sound Blaster Pro, whatever number designation it had. I had the first Sound Blaster 16. I was very much into following what Creative Labs was doing. So it didn't take me too much to catch up with that because I sort of already knew. I just needed a refresher. So these cards are sort of compatible, plug and play on ISA kind of stunt. Didn't work. And we already reviewed the story of the Shark Barker, so nothing to say there. But there was an ISA Sound Blaster in my card archive in the basement. So I tried it, but no. The story here goes, the 2950 is a Vibra, which is a low-cost line. It was designed to plug and play into a Windows 95 PC. This is a 5-year older model, and the standard driver doesn't work. Someone at Creative Labs solved this with a utility called CTCM, which is how I configure the card without Windows and manually setting up the settings. But I already gave away the end of the story. This doesn't end well. It configures admirably. It detects everything. It sets the standard Sound Blaster 225.1, or if you remember, the first version was 227.1. All good, but it didn't work with the software tests that we did afterwards. So let's see, how did it fail? The software is surprisingly slow, given that it's only manipulating text strings. That's a good point. But who knows what language they wrote this in? It certainly wasn't Perl. So basically what this utility does is reads your autoexec and config and edits things and adds things. It should really be super fast, but it's not. And it probably didn't matter at the time because plenty of people were running things off of floppies. So probably that wasn't necessarily the biggest bottleneck. And so we finally get our Blaster environment in place. Everything is the way it should be. These are with the standard tools. First, you use the compatibility tool for non-Windows, and then you use the standard install. And then you can use the very cute terminal graphics or NSI graphics test program that comes with it. And let's see if this will play. Is this no, this is just a picture. Then I have a couple of speakers that amusingly are USB powered, so I had to bring in a USB battery to make them work. Let's see if, I don't know if you'll be able to hear it, but So it works. Right. So we have audio, video, hard drive, RAM. So the next thing is we have a keyboard, but we have no mouse because that was also not standard on PCs. So Logitech, other than Microsoft, Logitech was the other big vendor of mice at the time. So we went with this one, which was similar to what I had back in the day. I found very nice edition, still in the original box. Oh, here is what didn't work on the audio part. So the audio did work in the tests, but then I tried installing Silent Service 2, which was really one of the most fun video games of the era, and that had spectacular sound. And it's a submarine simulation. You're running around the Pacific for the duration of the Pacific campaign. And like video games of the age, had really ridiculously good manuals. So you would get an education into submarine warfare and World War II history of the Pacific campaign by playing the game. It was really fun. You had to know where the next battles would be to have the best probability of engaging the enemy fleet. You had to recognize ships of the opposing fleet to do the copy protection check. So you'd have to go in the manual and identify the ship using charts in there. And so this one was probably one of my favorite games of the age, and I wanted to try and get it working here. Joystick was another thing that was not standard on PCs, so that didn't worry me too much. But first, it asks you if it needs to look for a joystick. Then it asks you if you have sound, and then it locks up. And it turns out that Silent Service, I thought was Sound Blaster compatible, but it is not. It is AD-lib compatible. AD-lib was, I believe, a Canadian company that made what we could consider the first sound card for PCs, first widespread sound card for PCs. And the original Sound Blaster, the 1.2, was AD-lib compatible. The ones that came later were essentially Sound Blaster compatible. And so our not PCI, not plug and play card may have been Sound Blaster 2 compatible, but it certainly wasn't AD-lib compatible. So it wasn't going to work for this kind of retro gaming. So I wanted Silent Service 2, Sword of the Samurai, which is a similar contemporary game with nice sound, and the original Monkey Island to play nicely. So I went into a bender about figuring out the sound part. So I went back into the archive and found, yeah, I know that sounds funny, but I have a hardware archive in my basement. It's only small things, but they're in a very neat cabinet. And so in the retro cards that I've kept, there was a Sound Blaster 1.5, which is a pretty expensive and delicate card. So I didn't want to pull it out, but it was necessary because the newer one wasn't going to do it. So put that one in. And there are a few details here that will pop up. So you see that there are a few chips, sockets that are missing here. And these were in for compatibility with a sound chip that I believe was called OPL32. So an early Sound Blaster like this one would give you compatibility for Sound Blaster, compatibility with AD-lib. But since we're looking at going a little bit into the late 80s there were two cards besides AD-lib that was not common but did define the beginning of sound for video games. There was another card that was called Game Blaster, that was essentially something that Creative Labs made for Radio Shack. And it was a relatively cheap card back then. Now it's really expensive. Um, and it used these Yamaha chips to do sound synthesis. The Sound Blaster did not ship by default.
Live streaming is on.
Was also looking for potentially blown up capacitors, but I haven't seen any on these. So congratulations.
Electronic caps too. That's remarkable.
They sourced good stuff.
Yeah, must be.
I can see a collection of resistors over here. So another thing that's neat about this PC is that you can open the cabinet without having to remove all cables from the back, which was a really annoying thing that many PCs had. You can pull it back half an inch and then it will lift up vertically. And yeah, when you're doing all of these trial and error debugging things, it really helps. The other thing that you'll see here is that I tend to put stickers that say off on VGA ports when I turn them off, because you forget. So this one has the ET400 card, and the VGA is this blue thing up all the way up there. But once this has been put away for a while, who knows if you'll notice that or if you'll try to just plug into this VGA. So I try to stop myself from doing dumb mistakes. I have quite a few data center machines that I labeled that way because I may have, for example, I don't know, a remote management card installed, and that takes over the frame buffer, so the original VGA port is disabled. So it's a convenient way to do things. Here in the back, you can see power connector all the way back. The gray connector is the Logitech mouse that we were talking about. And then there is an audio jack. And here there is an actual potentiometer wheel for the volume level.
On the back panel, a nice convenient spot for a volume knob.
All right, so here I'm reminiscing about the fact that these are configured the manly way, which is with jumpers. So you can see the IRQ setting down there with one jumper. The original Sound Blaster 1 series was configured with IRQ 7. And then I believe the Sound Blaster Pro switched to 5 as the common configuration. I actually seen somebody in the retrocomputing community challenge somebody else on Twitter a few weeks ago saying IRQ 5 or IRQ 7. It's kind of cute. There was the memory address also, which must have been another jumper, and I don't see in this part of the picture. And I can't remember if there was a jumper for the DMA, but yeah, that's how you set it up. Besides the jumpers, all that you need to do for this one Sound Blaster is set up some environment variables and you're done. No drivers whatsoever. So that's a nice contrast with what we went through for the plug and play or not plug and play scenario. And now we have the sound worked out. Now, because these things tend to be spread in time to whenever I have time, and because I forget, I leave myself notes inside the system. So there are usually cards that describe what the system is, like the specs. This is a 386 16 megahertz, 16 megabytes of RAM, SangLab ZT400, 4000. The Sound Blaster, you can see, has been erased and replaced, is a 1.5 CT1320, so the 1320C, not the very first one, but the 1320s were the first run of sound blasters, basically, for most of the world anyway. A220, i7D1T1 was the environment configuration. Here is the spec of the hard drive, which is a Fujitsu, as we said. And right, we didn't belabor the point. I didn't want to click at the IBM keyboard on this. I just bought a Mitsumi, which amazingly are still made. Mitsumi standard PS2 keyboard, which you can just get on Amazon, and they look exactly the same they did in the 90s. And then a little bit of notes of what's where and what's being tested as working and so on. Because I'm sort of a network obsessive, this is DOS, so there is no networking. Everything has a name and a host name whenever possible. So this system has been christened Razorback. And here there is an interesting stamp from the production line. We don't know what this exactly is. There is another sticker here in the corner that explains how to turn off the onboard VGA if you're going to install an external one by jumpering the motherboard to turn off the built-in one. In some cases, you could do that from the BIOS, but the system is so old that you have to do it from jumpers, like everything else discussed. So
regarding the mystery stamp, that looks like the 199-1715 looks like a Julian day and a 24-hour time.
That's plausible. Something for the production line to know where it came from. Here we get to see the box of the Mitsumi keyboard that also looks exactly as it did in the 90s, but I can assure you it's a brand new one. And here we try with the silent service install again, and it gives you the option of installing it on floppies or on a hard drive if you have one, because what is this, 1990, 1991? 1990 it says. So hard drives were not exactly common. Installs in a subdirectory of MPS, which stands for Microprose, which was, I believe, a UK-based game developer that made quite a few cool games in the age. And now we're actually getting the installer to work because we have the right sound card. And yeah, here I'm commenting that it's all floppies, so it's all zzz, zzz, zzz. And it works just fine. And this is Microprose Latter Day logo. I'm pretty sure that logo wasn't there in the original 1990 version. I think it was added later. It seems, oh no, I know what it is. When I played this game, my system was CGA. Well, this obviously is a VGA. So must have looked very different on the CGA that I had at the time. There is a splash screen for some of the games that they made at the time, which were all pretty famous. I remember playing F-19, F-19 was the presumptive number for the F-117 when the F-117 was classified and nobody had seen it or heard about it in public. Well, Tom Clancy and generally all the military buff community was speculating. Obviously, the video game was made using what the speculation was of a stealth fighter, but it wasn't the actual F-117. Microprose relabeled and rebranded that game a couple of years later when, after the Gulf War, the F-117 became a public thing. But until the Gulf War, nobody knew anything about the F-117 outside of the Air Force. So that's what it was passing for. Similar simulator. This was actually pretty cool because you had to fly around in certain missions and maintain stealth to survive. The F-15 one was more traditional flight simulator, where you just fly around and shoot at things and get shot down. After the obligatory ads and many credit pages, we get to the login screen, which is actually pretty cool. As it's loading the game slowly, that water effect is actually animated, which looks pretty cool. And because of all the effort that we made with the sound cards, it has a very nice background music. And yeah, this is some of the credit screens. Oh, there you go. So we go back to the sound card because these were written in real time as things happened, right? So I got the chips in the mail. These are the sockets for the Game Blaster compatibility. The OPL 32 or whatever it was called, missing chips. There is this, I don't know who the speaker was, but there is a YouTube retrocomputing guy that has basically an entire hour-long talk on all the sound cards of the age, and I've given you the cliff notes of that, but he goes into even deeper detail, and he tries them with different games on different cards. It's kind of interesting if you have an hour to waste to reminisce and seeing how the different things sounded different. So, oh, these are not the Yamaha chips. These are Philips chips. I apparently managed to stab my index finger with one of the pins. There you go. That's when you don't work around discrete components for a long time. The chip was fine. My finger will heal. So because old hardware has rust in places that you don't expect, even in minimum quantities, deoxit is really cool. When you're restoring a system, you go and deox all the connectors. So I did that before inserting the chips. I did that in all the serial and parallel ports so that there wouldn't be a question of whether the connections were clean or not. And so basically we get the upgraded Sound Blaster that is even more compatible than the original Sound Blaster that I had when I was a kid. So this should support games that use CMS, which there were a few of them in that use Game Blaster, which there were a few of in 88 and 89 before AD-lib came out. And with these games with limited graphics, actually sound makes a huge difference in terms of the experience being more immersive. And so now we have the ultimate in music compatibility. This machine can do Sound Blaster, AD-lib, CMS, Game Blaster, and PC speaker. All of them are covered. If you have an old sound system, it's all compatible. Then we go and continue the thing, the Gibson theme. Hosaka, if I remember, was the maker of mainframes in Neuromancer. And most of these systems have notebooks that I leave with them where I note the various things that are needed to run these things. Obviously, I can tell you the story, but I remember half of what I did because these things are incredibly long-winded. And I have to say one thing. We complain about computers all day today, but back then you had to thread the needle of the one thing that would work on a PC. Maybe if you had a higher-end system, they were designed better. But PCs were incredibly temperamental machines where you had to try and try and try again until you got the right thing. Having a notebook attached to the machine is essential for me so that I can write the recipes of what I did to get what working. And if I need to do it again, I don't spend hours figuring that out again. Doing it once is fun. Doing it twice is insanely frustrating. But the thing that is the thing that's interesting is that a lot of retrocomputing is really the challenge of getting the old hardware to work. You don't want to do it twice, but I think that the first time is really key part of the fun. And if you don't enjoy that, you shouldn't try retrocomputing, because nowadays we are used to these things, and the usability of things like iOS is really off the charts compared to anything of the era. It's difference between stabbing yourself in the finger with a knife and eating donuts, kind of feeling difference. So you have to enjoy the hunt of figuring out a system that's not working, kind of like an embedded engineer would. And then you can enjoy the game. That's also fine. But if you don't enjoy the embedded engineering challenge, you can play the old games in virtual machines or in DOSBox, and save yourself all of the hardware discovery. But I was a hardware engineer. I'm sorry, I was an embedded engineer. So I kind of enjoy solving these mysteries, especially, when you're doing it for real, you don't know that there is a solution. You don't know, okay, is the chip shot? With these challenges, it's kind of easy because you know that there is a solution. You know that the sound blaster worked before. It's like, okay, is the capacitor bad? Did I use the wrong component? But you know that there is an answer at the end of the tunnel. It's kind of like a capture the flag exercise. You know that somebody has put something for you to find there. So we were talking about backups. So we find another staple of the age, the zip drive. So these are where one platter disk drives, hard disk drives basically, on a drive, so that you could have 100 megabyte floppies, a little bit thicker than floppies. And I guess getting some advertisement of what I was reading at the time there, which gives you an idea of the scale of the box too. Um, Zip drives were revolutionary in the scale of the fact that they allow you to have 100 megabytes for not much money. They were very cheap compared to buying a hard drive of the same capacity. They were fairly reliable, although they tended to break suddenly and making this clicking sound that's known as the click of death. So they worked fine until they didn't. And this is going to be my strategy for bringing software in and out, because don't want to use floppy drives forever. Moving things at 1.44 megabytes gets old pretty quickly. So this one, actually, let's finish the story here. This one is a parallel one. There are versions that have SCSI, and there are versions that have both compatible on the same machine, on the same box, which I had never heard of. I discovered recently. So this one is a parallel one because the PC had the parallel port. So we'll see. This is really at the edge of, is the parallel port good enough to do a zip drive? So there was that question. Turns out that it is. NCR sprung for the best chipset for parallel ports, so it worked fine. And then iOmega, the vendor that made this, had a SCSI over parallel port drive essentially that would mount the drive and make it work as a local hard drive. This is the way it looked. Parallel port cable, bunch of documentation, the inevitable registration card that we keep making fun of. And here is one of the disks. They would come pre-formatted for either DOS or Mac, because formatting them takes a while. But other than that, they're compatible with both. So I went a little bit overboard, but I decided to make my life easy. So I decided to make this ultimative compatibility kit for old machines. And so it has two zip drives, one that is parallel, and later I replaced that with the dual parallel SCSI version so that it could do both. But it's really parallel that matters to us here. And another one that's the USB zip drive, which is the funnier looking one on the bottom of the picture here. The USB one you can connect to any PC of today, and and mount the 100 megabyte cartridge in it. You load the software that way, then you take the cartridge out, you go to the Retro PC, mount the cartridge into the 100 drive, and there you go. And you're transferring 100 megabytes at a time instead of 1 megabyte 44. So great as a way to save your lifespan.
Excellent.
So here it is. I had to do a little bit of deaux on all these connectors as well. Discover a few details of formatting, but nothing too dramatic. And yeah, you can see that the cartridge is essentially the same size as a floppy drive. And you can tell that the Mitsumi keyboard is a modern one. It has the Windows key here, which wouldn't have been there on 90s model of the keyboard. So the zip drive had two versions of the drive. One that you could load as boot time driver, so something that command.com, I'm sorry, something that autoexec.bat or configsys would load. But there was another version of the driver that was called the guest driver that would load resident in memory, what in DOS was called a TSR. So DOS was a single non-multitasking operating system. But a TSR program would basically load itself in memory and task switch in and out at regular intervals. So essentially, it would allow two programs to run on one PC. That was an interesting strategy for a driver, but because the performance of these drives was limited, it was fine. And it essentially made plug and play, made the zip drive something that you could plug and play on a working machine, because you could just load the driver without rebooting. Not something that we necessarily need here, but that's the first place that I went because it's the easiest drive to work with. And as you can see, running into some problems, so deaux everything to make sure that the hardware connections are good. The drive could work vertically or horizontally, but this one is starting to suffer a little bit from its age. So it prefers horizontally. It doesn't eject correctly on vertical. So I spent quite a bit of time dealing with the driver. It would just lock up. And eventually, because the actual iOmega driver was locking up, there is this other driver that's called PalmZip that's made by an independent developer, this gentleman Klaus Peichel, and it's essentially shareware. So you can try it. It will work for 7 minutes, and then it will turn itself off unless you buy a key. So Klaus's driver worked, which told me that the hardware was fine, that I had something else that was wrong. So since the TSR, since the guest drive is a TSR program, and TSR programs didn't always work, they weren't exactly as standard, they were sort of a hack, I went back to the boot time driver. Since now we know that the hardware is working, so the fact that we're going to reboot this machine 10 or 20 times to get the configuration right is time well spent. So we get it set up, and it works. So now we have a way to bring in hardware, bring in software at a reasonable pace. Then the last thing that I wanted to do was cleaning up things, because in gaming, in DOS gaming, the lower memory, so the first 640K, which are never 640K, but whatever is left of the 640 after the OS loaded, were a critical variable for games. So it was important that you didn't put too many things in the configsys or in the autoexec.bat, the things that preload at boot time, because they would eat into that memory, and then the games would not play. Wing Commander was notoriously difficult here, but Wing Commander could also use extended memory. Falcon 3, a flight simulator for the F-16, was probably the worst of all. It really wanted all possible memory, and you really needed the latest versions of Microsoft DOS to free as much of that as possible. So to not waste memory, I essentially started creating boot up configurations in the AutoExec and loading the drivers only when they were necessary. Now, the syntax for AutoExec, bat and config.sys and the conditionality in there is straight out pathetic if you're used to something like the Unix shell. Like Bash puts all of this to shame. But it's also kind of amusing that you have to figure out this very specific syntax for what the options are going to be and where the right spaces have to be and what characters can you use and not use in the labels and stuff like that. So if you're masochistic that way, which I guess I am, you basically puzzle the riddle of 20-year-old documentation until you get it. And so here is the foo.txt file that I loaded on the Mac as the test thing, and it made it all the way here. So our chain of floppy drives is working. All right. So now it's going just fine. And we're loading Sword of the Samurai from, I think we're doing it from the zip drive. Sword of the Samurai is another Microprose game. I was a big fan of Microprose games. And it's even older, a year older than Silent Service. And this one is another one that requires ad-lib for music. And now with all these tweaks, it's working just fine. And so that's kind of the tune that's playing in the background. Sword of the Samurai is sort of a strange game to classify. It's a little bit of fighting, a little bit of strategy, a little bit of adventure. You are essentially a samurai in the Tokugawa period of Japanese history. You are in charge of well, initially you are just you, and you are a samurai working for a daimyo, a feudal lord, and progressively you climb through the ranks. You start building a family, you marry, you have children, you start a house, so to speak. You may become a hatamoto, slightly more senior vassal of the daimyo. And then basically this continues to go through fights and different kinds of political conspiracies where you do either overt combat or covert combat, where you operating as a ninja, you go into a competing lord's house and you kill him in the middle of the night, or you kidnap their family and dishonor them or something crazy like that. And you basically very slowly climb through the ranks. Eventually you die. Your children take over for you only if you have a male heir. And so basically it's the history of this family and how it climbs up. And there are different interaction modes. Basically you're moving through the landscape. You're fighting in sword battles. You're fighting in sort of landscape battle engagements. You're fighting in one-to-one battles. There are all of these different designs of the interaction that you flip through. It's a game with a lot of different modes. So initially you choose what. Actually, you don't get to choose. You start in Satsuma, which is a significant province in Japanese history, and when you get later into the game, you're actually conquering the provinces. Eventually, you get to be the shogun of all of Japan if you're really successful. But is going to take you quite a bit of time. You don't get to choose what domain you start from, but you get to choose your name. And for some reason that is lost to history, I was always Ukio, so I was Ukio again here when I took the screenshot. You have peers that you support openly and sabotage behind the scenes because you want to be the best of the four, so that your boss will decide to promote you when there is a vacancy in the org chart, to put it in modern terms. The strategic part is very deliberate, but there are parts with basically at every round you get additional, you get to recruit new samurai working for you. This is at some point somebody comes with an offer to marry their daughter and build a family that way, and these have implications in terms of whether you marry up or you marry down, but they also have implications in terms of you want to have heirs so that you proceed to the next round. It's a very strategic game with a lot of different choices, and then between the strategic parts are the interactive parts, which are these 4 different modes of battle, where either you're battling alone, or you're sword fighting alone, or you're leading an army. It's cool, but it is a 4-color game, as you can see from from the graphics. Maybe it's a 16-color game. There we go. So then we try for something else. Doom. This should be the most that this machine can do. The copy of Doom that I found was not complete. It did not have its configuration utility, so I had to go in and manually edit the config, which was funny because you see sound SB port, sound SBRQ, and all that, MIDI port, and all of that. So these numbers are decimal representations of the usual numbers, like 220 for the Sound Blaster. So once I figured that out, it was pretty easy to patch it by hand. And so now it works with sound. That is fine. This software, like most other software, came from the Internet Archive. The Internet Archive doesn't have just copies of web pages. It has a ridiculous number of pieces of software archived in floppy image format. Doom works. This is a 386, and as you can see, clearly the limit of what this. Uh, back, whoops. Back then, I did play Doom on a 386, but it was not an SX. It was a full 386, and it was the special AMD 40 megahertz version. So it was and it worked just fine. But
if I could interrupt for just a minute, it seems like whenever you mix in sound from the video or computer, I'm not sure which, your vocals start breaking up. I think it's echo cancellation gone bad or something.
So I should only speak or play music, not do both. Okay. So yeah, this is at the limit of what the chipset can do. The machine that I played Doom when it came out was a 16 megahertz. It was a 386 40 megahertz full-blown 386. This is a 16 megahertz addled 386 SX. So the difference shows. It has a lot of memory, which helps, but not enough. One thing that is theoretically possible to push this machine even a little bit further is that there are some chips that clamp on the existing CPU. They were made starting with 286, and they were kind of really extreme things there. They're fairly wacky on the 386 SX also, but they do exist. And you basically would be able to replace the 386 SX with a full 386 or with even a 486. The problem is that this is a 286 motherboard essentially with a 386 chip in it. So we may get a lot more CPU, but in and out of the CPU, things are still going to be relatively slow. I think it may help with Doom. I think that Doom is really running out of CPU here, but it's really hard to find these accelerators. There is one on eBay right now for $950, which is ridiculous. I think most of them were destroyed at the end of the 90s when nobody really needed them anymore. So it's really hard to source them. But potentially that could be the last upgrade of this machine if we wanted to push it into Doom territory. And Doom 2 was essentially the same thing. It was just a different collection of levels. You see that graphically it renders just fine, but frame rate is nothing to be impressed with. Sound works fine also. Let's see, there is another bit here. Mostly going through the menus, looks like. But the menus were done rendering the actual game, so it's a good rendition of the speed that was there. And I switched to Doom 2 because this version from the Internet Archive had the full installer, so I could get the configuration in properly just by going through the installer rather than hacking it in as I did with the other ones. And it was shareware, so there were these funny messages. And that's pretty much where this project stops, because that's the limit for what the 386 can do. So Microprose games are going to be fine. Monkey Island is going to run fine. Police Quest and King Quest, which were popular adventure games of the age, would also run fine. Doom is not, and I think that it's possible that putting this CPU may be the way to do it, but that's where this project stopped so far. And it looks like I left some pictures out on the side, so let's see what they are. Probably an aside or some comment. Oh, no, we've already seen this. Let's just check that I didn't skip anything. No, I didn't. Good. So we don't need to keep that. Now, let's go to some other projects. This one was basically giving you an idea of all the problems that are happening when you're running old hardware, but then after you go through this, you get slightly more ambitious. So what did I try next? Now, when I was a kid, I had an Amstrad 286 laptop. That's where I studied mostly Pascal and then C. And laptop is an ambitious word for these monsters. They're the size of a typewriter. I found the 386SX of the same. I incidentally still have the 286 of my Amstrad laptop, but I don't think it's working anymore. It has aged badly. And this thing is built like a tank, so you wouldn't put it in a case or anything. You would literally carry the thing. There's a built-in handle. There is a side connector for a standard PC keyboard. And then at the back, there's a standard power cord, power switch, fan. Pretty amazingly, this had a half-size ISA 16-bit bus expansion here under the cover on the right. It had a parallel port, a serial port, 2 serial ports. Then there is an array of dip switches to configure some of the hardware. And it had an internal VGA that you could connect to an external monitor. It was a pretty ambitious system for the age, and Amstrad was not a vendor that was common in the US, but it was very popular in Europe as sort of like the way Packard Bell was here. Systems that were reasonable but more affordable than what you would get buying from the vendors that shipped primarily for enterprises. This is the handle there I was mentioning, and typewriters at the time had handles just like these. The battery is this brick on the left corner. It's a nickel cadmium battery, if you can believe it. This monster is amazingly heavy. But it didn't matter because back then we were so excited by the idea of a computer being portable that it didn't really matter if it weighed 10 tons. This had a floppy drive on the side, a 3.5. There was this big proprietary connector. This is Centronics that's being used for a bunch of things, usually printer connectors, but Amstrad used it as a proprietary extension to have an external 5.25-inch drive, which back then I had, but right now I don't need because we have our zip drive tricks that I highlighted before, so that doesn't really matter. Funny thing, 5.25-inch drives were actually faster. They had less capacity, but they were faster than 3.5, which is actually something that product managers like to go back to when we talk about innovator's dilemma. Because when you look at drives, hard disk drives, floppy drives, it doesn't matter. If you were looking at what the customers told you, the customers of the drives were telling you faster, faster, faster. No one was coming around saying make the floppies smaller. So at every generation of transition from like 5.25 to 3.5, there are very well documented cases of essentially lots of companies dying and new set of vendors coming up because they would get blindsided by the emergence of new technology because they were listening to their customers, essentially. This is very notable on hard drive vendors, but the physics applies just the same, and floppy drives of 5.25 are faster than 3.5, which is something people are always puzzled by. Newer technology is slower than the old one. There were these lights, power, hard disk drive access, and system on. The dark one here is hard disk drive access. I believe it was yellow. And the keyboard here was pretty much full-sized with no number pad. The screen had limited visibility, but it was considered amazing at the time to have a screen built into the system. So just like the IBM PS2 Model 70 I showed you earlier, people accepted the limits of LCDs just out of the reality that having a screen that was portable was quite something of its own. I also maxed out the memory here, but I don't remember what the maximum on this system is. Oh, we'll find out. So we're booting, everything is working fine, but there is nothing on the hard drive. This system also had a bad hard drive. Oh, this one also had a similar problem in terms of hard drive types, but there was a type, I don't know what number, on the high number range where you could enter whatever number of cylinders and heads you wanted. So it was much more compatible than the NCR machine. Oh, I'm sorry. I should be full screening this. All right. So 70 pins DIMMs. And the note here says that the machine can go all the way to 4 megabytes. The two ROMs up here are the BIOS, so it could be graded separately. And here there is a socket for a 386 coprocessor. Intel didn't merge the fast math into the CPU until the 486. So if you wanted the faster floating point arithmetic, you used a coprocessor. And in the case of the 386 SX, it would have been a 387 SX that would have gone here. In some cases, you could actually have a 287 because they were the same bus type, and some people did such horrible things, but the 287 had a different socket, so you couldn't do that here even if you wanted. So apparently there was some dip switch gymnastics to configure the memory setup correctly, and eventually it got recognized as oh, there you go, setting things in that bank to indicate that there are 4 megs of memory. And as I was saying, I still have my original one, which I pulled out to borrow parts because the 286 doesn't work anymore. I've kept it very nicely because it's, well, I had an 8086 before, but this was really the machine that I learned my trade on. And it's not working anymore, but the case is in perfect condition, and we can pull parts from it to make the 386SX work. So while I'm at it, I have multiple banks of 70 ms memory with the right size. So why not put 4 megabytes in the 286 also, just in case. So I'm doing that. Firmware for the 286 BIOS is up here, and you can see here at the bottom that the 287 looks markedly different in the 286 machine. It has a long package casing instead of the square one of the 387. Still no OS, of course, but it's still working, so we're good with the hardware. I like to label things that are mine when they're transiting through the office so that nobody gets confused. Also because I have different things, like things that belong to me, things that belong to the company that my wife runs, things that belong to Red Hat, things that belong to IBM. It's a mess. So I label things with who owns them, and the fact that I'm the asset controller. And then the other thing is, what is the project? So the restoration of the 386SX is in my books and files is Project RD78. So there you go. A little bit OCD, but it helps. So before we go to the software, we poke at the expansion slot. This is, there's basically a plastic cover to insulate the rest of the machine, and there is an ISA 16-bit slot, as it would have been found in a PC-AT or a 386 with compatibility. So in this one, I've installed an NE2000 network card. This is a network card made by Novell. It was the most compatible network adapter of the age, and there were DOS drivers for it. So this could potentially get interesting in terms of getting on TCP/IP with a 286, or as far as you can possibly go. There is a lot of attention to detail in these machines. I don't have the pictures here. Let me see. Maybe I didn't tweet that. But the last step, which is still outstanding, maybe that's why I didn't tweet it, on this project is that that the floppy drive is not working. And we need the floppy drive so that we can get MS-DOS in and get the iOmega drivers in, so that then we can switch to zip drives for moving things. And no, not CPAN today, just Twitter. Let's see if I put it up under a separate thread. This would be a PS2 floppy. So the interesting thing is that IBM made a different standard. And there you go. So there is a picture of this. When I opened the machine to get the new floppy in, I found one with the right bezel and the ability to swap it, but it turned out that this machine has PS2 floppy drives. When IBM made the PS2, they actually made a standard they made a different standard for floppy connectors where the ribbon cable would also carry power. And so the first thing that I tried is getting the drive that's in there, opening it up, and do the treatment that you should do to any floppy drive of its age, which is you rub the heads with isopropyl alcohol to clean them. And in about half of the cases, floppy drives will work after you go through this exercise. So it's definitely worth it. This is a dual head drive, like any 1.44 megabyte floppy should be. Can see the reading heads, and you just swab them and make sure that they're clean. With a lot of floppies, this is sufficient. Not in this case, however. But I had to go through that exercise anyway because I needed to see the model of the drive. And but then remember, we have two of these, so there is another floppy. So we open a second time, and we transplant the 286's drive. And this is actually a pretty complicated system to open, as you can see. There are all Phillips screws, but while it is, while it is serviceable, you have to have a map of the screw configuration, like I implicitly had here on the table, with the layout of where goes what, so that you put everything back where it came from. Unfortunately, I'm going to spoil you, but want to speed this up a little bit. It did not work. In fact, this one fails even worse. So now we have two very hefty laptops to reassemble, and we go through that. One thing that we do get to do is putting the 387 coprocessor that in the meantime arrived from China. A lot of these old chips can can be mysteriously sourced from China, like everything modern. Apparently, they have also lots of the old stuff available. They have everything. So either eBay or Alibaba will get you what you need. Most of the parts that I have had to order were from eBay from the United States or eBay from China. The only exception was the CMS chips for the Sound Blaster. Those I got from New Zealand for who knows what reason. It took almost a month to get that letter, but okay. The chips worked, so no complaints. So we get the 387 in, and the BIOS detects it correctly, so we have a valid coprocessor. Looks like we're making progress on the hardware, but the floppy is still missing. And you can see that I have ambitions that involve Quake up there, but we're not there yet. In terms of decoration, this guy gets the Phoenix Foundation logo. This is the original Phoenix Foundation logo from MacGyver, which actually looks pretty darn awesome. So I think in terms of the restoration work, we're done, but we need to find the floppy. And that's where this is stuck right now, because sourcing at PS2 floppy with the power lines on the ribbon connector has so far eluded me. And not even Foon had any suggestion of what to do about that. So maybe I'll try to repair one of the floppies, one of the floppy drives that I already have. After all, I have two. I can risk it. And they're not working anyway, so why not? These are all pretty large components, so going in with a tester and figuring out what's going on is not out of the question. But that's where this project is right now. Now we're getting to more exotic hardware. Let's see. So we did 2 386. These are, I learned as a PC person. I joke that I was the uncool kid with a PC, because in the 90s, the cool machines were, at least in Europe. And the US, there was the Mac, obviously was cool, but very few people had the Mac in Europe. The Mac successfully sold in the US and Japan primarily. And so in Europe, it was all PCs for the serious people like me, or there were Atari machines that were Atari 16-bit machines that were quite popular because they were the best price to performance in terms of what you got in terms of RAM and CPU strength. Atari, obviously a US company, but they were very popular in Germany, and that dragged some parts of Europe along. And it was systems that were popular for music among professional applications. In Germany, they were also used for actual work. And then there were gaming machines or home machines, homebrew machines. Commodore was around, obviously. 64 was an 80s machine, but the Commodore Amiga was surprisingly popular. And a few things like that. But the uncool kids like me had PCs. So that's why I learned programming more than gaming. The Commodore 64 was out when I was maybe 6 or 7. So was a little bit too young, but I was curious to see what actually did this machine do. So the next project was restoring a C64. Didn't want to go into capacitor swapping or anything like that, so I found someone that had already restored anything that needed to be cleaned up and replaced on a C64. And for reasons that I won't go into, I had an actual Commodore monitor in my archive. So pulled that out, and the combination of the two actually works on first try. Here is what the video does. Oh, there isn't much on the video. It's just that, well, you can see the cursor blink. There is one thing that's interesting. All of these pictures are taken with an iPhone, which has amazing macro performance, I must say. But one thing that old monitors do to the iPhone is that you can see the refresh rate in the picture. You can see a black band of where the screen is being refreshed. So in a lot of cases, I've taken pictures as video because the synchronization of the iPhone doesn't do that with video. So C64 is working, but no drive. I only have the keyboard, which the bread box, as they called it back then, which has a bunch of bus ports in the back, and it has the CPU underneath the keyboard, and the monitor. But I don't have a cassette player, which is what most people used back then to load the programs, or a 1541 floppy drive, which is what the well-off would have used for this purpose. Given that we have already learned enough of how difficult it is to deal with floppy drives, I don't want to figure out how to load some.
Live streaming is on.
Someone made a board that you put on a Raspberry Pi and will produce a timing accurate, clock timing accurate emulation of a 1541 drive. And the other thing that you do is you load software into it with an SD card. So say what you will about SD cards, but they're a lot more comfortable to work with than trying to do Commodore 64 floppies in this day and age. So ironically, the most expensive thing here was finding a Raspberry Pi during the supply chain problems that we have right now. So this one could work with the 4 or with the 3, and we went with the 3 because it was cheaper, but it was still the most expensive Raspberry Pi I've ever bought. So supply chain sucks. So then we need to make the firmware card that will make this work. All right. By the magic of Macs, really speaking, almost everything, I am doing it on my Mac again. Actually, I have to say that the most amazing thing was I was able to do everything on a Mac with an SD card port, except one thing, which is floppy disks for System 7. And that's because Apple removed HFS support. HFS is the file system of System 7 in write mode. HFS in read mode is still present today, which is crazy. Or maybe they removed it a couple of releases ago, but it was present well into the tens decade. While they removed the write ability of HFS with Mac OS 10.5, I believe, whatever Tiger was. So I pulled out my Tiger machine, and that's how I wrote my HFS floppies. But everything else I was able to do from a modern Mac. So some people like to accuse Apple of planned obsolescence, but really they've shown more compatibility than anything else I touched here. So we're creating the file system with all the bits that are needed to boot the Pi 1541. Amusingly, I managed to put things in the wrong floppy. I'm sorry, in the wrong directory because I was in a little bit of a hurry, but eventually worked it out. You need lots of Allen keys to open this case, but that's fine. And people are so used to know that I have hardware around that sometimes even facilities comes asking me for hardware. So you open the case, there is the extra board that's built into the case, and then the Raspberry Pi, and you load it in, and that's essentially all you do. Funny aside, there are two different sizes of bolts in this. So one is metric and one is not, if I remember correctly, but okay. It happens. The instructions are printed on the board, which is cool. you see the two Commodore type. These are similar to the PC keyboard connectors up on the right. And then all the buttons are how you interact with the drive. And basically, you navigate directories, you find the image of the floppy that you want to load or the program that you want to load. You select it, and it feeds it to the Commodore 64. Right, the hex bolts are of two different sizes, as I said, but hey, I came equipped. So after all the integration is done, we go for the software, and it doesn't work because it's computers, of course. So all this red suggests something is not working, although it looks really cool. Red is power on both the Pi and the Pi 1541, so maybe we can hope it's just power, but it's not, because you see here it's flashing 7 greens, which on a Raspberry Pi means where is my kernel? So the boot image is not where it should be. So it was in a 4th download that I skipped in my list. So I put that back in. There is still a problem because there was a directory that was not in place, not in the correct place, but then it got fixed. And then the system is working, and it's showing us CCGMS is a terminal program for modem connections, so BBS dial-up, if I remember correctly. And those are the files that are there. Now, what we want to do with this, here are the files laid down in the correct place. And then we hack the configuration as well so that it produces the right LCD output and everything that's needed to work in this environment. So the project supports multiple boards, and we made it correct for this board. Then we have the cables. One thing that I find disconcerting of the Commodore 64 is how cables look the same. Like one of these is a keyboard connection, the other one is a video connection. They are pin incompatible, but you find yourself staring at things quite a bit, trying to figure out which is which. And the power supply is the size of a brick, literally. But it works, so what are we complaining about? Now that the C64 is working, the real challenge, getting the C64 on the interweb. So again, in terms of work done, modern work done, there is somebody that makes modems for Commodore 64 that are modem on one side, Wi-Fi on the other. So that's how it's going to play out.
Federico, is that power supply you showed, is that an original Commodore power supply?
Yeah.
Actually, I've heard that all the Commodore power supplies, the original ones for the 8-bit computers, they can all possibly fail into a bad mode where they give overvoltage to the main board and destroy it. So you want to get an aftermarket power supply.
That's neat. Thank you for the tip. Yeah, it's an original, and it's, whoever refurbished this machine was actually quite proud that it was still working. But yeah.
Well, they may have gone inside the power supply and made sure that it won't fail, but check up on that before you keep using it.
Understood. Thank you. So, all right. So the drive is working. We have software, which is a start. So we have hardware, we have software. And as I said, basically you navigate the directories over this tiny screen, select the file that you want to load, and off you go. But remember, I am not a Commodore 64 user, so I'm learning this in 2020, 2021, whenever this was. So there is also a problem with the Wi-Fi board. See, something is broken in the screen. It's not working quite right. So we're going to send that back to the manufacturer for replacing the screen. I forget his name, but he was exceedingly kind, and he replaced it for $5. Something happened in transit, nothing serious, but he desoldered the screen and put a new one in place. So we have it working, and we go and mount the drive. And then I'm going to make a rookie mistake, but I didn't know about it then. So this is mounting the drive, loading the directory essentially. And then the next thing I tried to do was listing files, which seems to work. These files here, FB and the number, are different resolutions of a file manager. So they basically are ways to navigate directories of files, which is nice, but not something we particularly need. We're just going to use it to try to see if we can run some program, any program. So the mistake that I'm making here, which you can see, is it says press play on tape, is that the syntax I'm using where I'm saying load FB64, I'm not specifying the device. So where in the previous one I'm saying load $8, load the directory on device 8, basically. But on the second one, I'm saying load the program FB64, and I'm not specifying 8. So it's going to its default device, which is the tape that I don't have. So eventually somebody with more clue told me, and we have it working with the right syntax, and we can actually get that working apparently. And let's see if there is a shot of the file manager. And because this is time accurate, it actually is just as slow as a 1541 drive would be. When you're loading the program, you can see the lights flashing. So the Raspberry Pi is telling you that something is going on. And then on the Commodore 64 side, eventually you get the file manager up, which, yay, we made it. By the way, the thing that I learned is that the Commodore 64 shell is a basic interpreter. So it's a kind of cool scenario where your shell is also a programming language. I don't know how much basic is in there, but it's an interesting hybrid. And so we loaded the first program. So the next one is here, loading CCGM, which is the program that we're going to use to connect to BBSs. We cannot really browse the internet, but we can connect to a BBS that's hosted on the internet over Wi-Fi, which is pretty ambitious for a Commodore 64. So CCGMS loads, and it works just fine. And then I think there was a hiatus because we needed to get the fixed version of the Wi-Fi card. And then there is an interesting thing, again, something I didn't know. So these, I was pretty familiar with the BBS system, with the BBS world and FidoNet on a PC, but on C64, apparently they had different ANSI modes. There was a graphics terminal mode and another mode, and they have this mode that they call ANSI ASCII or ANSCII. And because you need to configure the Wi-Fi card from the terminal to make it work, you want to be in terminal mode when you're doing the configuration so that no codes get appended in there. And then you want to be in the graphic, the ANSCII mode, to access the BBS. So I had to figure that part out. And the obvious part is setting the speed of the modem, which that's to be expected. So you go to 300 baud. You can go as high as 2400, and the Wi-Fi will support it. But essentially, they're so slow anyway that okay, it's an order of magnitude faster, but it's still slow as molasses. It doesn't matter. You can save the configuration actually, which is nice. It reminds you of a real computer. And then how do you interact with the Wi-Fi card? It starts getting interesting. So the way you configure the Wi-Fi card from the Commodore 64 is that you use a T commands, so standard mode, non-standard modem commands, and ATI will give you the configuration, and here you can see that it doesn't really have an SSID that it's talking to, so it doesn't know what Wi-Fi access point to go to. So that's the thing that I'm trying to fix, and I'm fixing it wrong because my terminal is in the wrong mode. So it's actually inserting ANSI codes in there that I'm not seeing. So then the authentication fails. And you can see a few attempts of this kind, and we can actually see the rest of the syntax. AT*N is scanning for Wi-Fi networks. So it tells me that there is a LaserJet 200 printer nearby, another LaserJet, stuff like that. Eventually, because I thought it would give a heart attack to anybody in the compliance team, and I'm doing this after hours in the office, I decided to set up my own Wi-Fi so that it's filtered from the rest of the network and people are not, security people are not upset. Now the fixed version of the Wi-Fi modem came in. Now we can start reading details. 300. Oh no, this is still the broken one. I can still see the chips here, but the speed that it's set to is correct, and it's showing me here that it's set up to 300 baud. And here on the left, it's trying to show the command. Although there are those missing lines because of the chipped screen. So I make a few attempts of this kind, and essentially never get to establish a connection, not because of the chip screen, but because of the ANSI codes that are going into the password or in the SSID, essentially both. So syntax problems, but invisible syntax problems, because these are the right setup and these are the right configurations for the guest network that I configured. There is one mode where you scan the network and then say, give me network number 2. There is another mode where you say network by name, so ATSSID SCAR with the password. Nope. But then when the gentleman that develops that board sent me the replacement, he also looked through and he checked the board for me, and he said everything is working fine on my end. So as we are going back and forth trying to figure out what am I doing wrong, he tells me to check for ANSI codes. So the default terminal mode is graphics, so it starts in graphic on its own, and that's the problem. So graphics is the one with more codes, and ANSI is the one which is more terminal compatible. So we switch back to ANSI, put the configuration in, and then switch back to graphics. See the fixed screen. Now we have all the correct characters, all the full characters. We get the modem manager on. With F8 toggles graphic modes, which turns out to be super useful because once you connect to the BBS, you want to be able to do that without going back to the configuration screen. You go through the same dance that I did before for the configuration. So here we go. Let's see if I can. Here I'm doing the scan. Showing base star is the guest network setup for the experiment. Star is the second guest network setup for the experiment. So then we go and we say,
Your audio is
next.
glitching again.
Oh, it's probably because there is sound on the.
Yeah, we're not getting the sound from the video, but it glitches you.
Yeah, can you hear me now?
Yeah, what is this? A Verizon ad?
So essentially here it's saying network number 2, password, and the connection succeeds finally. And here on the card side, we get the finally we get a green light. Name of the access point, speed of the connection, ready. So now we can actually open arbitrary HTTP endpoints. So the obvious thing to do is go to Google. So you do it with AT syntax, like as one does. Let me pause so you don't get the glitches. ATDT google.com port 80. Something happened the first time around. Try again. Connected to Google. So we could send HTTP GET requests here for what that would do. We can end the connection with +++. So here it's showing connected to google.com port 80, which is not an internet BBS, so there isn't anything cool there, but okay. And then +++ to signal no carrier and send the hang up command to the modem. So then there is Retrocampus, which is a BBS. It has a pretty elaborate login system that I think is both in Italian and in English, and slowly rendering. And this is the non-fancy mode where it's rendering just text. There should be another view of this. Oh, there we go. And this is the way it renders in graphics mode with colors and the like. And as you can see, it's amazingly slow. But that was the original speed of a 300 baud modem, so that's what people would see in the 80s. So this is actually lined up to be my April 1st joke next year. Although, as some of you know, the Ceph team is being transferred to IBM. So we will see how much of a sense of humor IBM has. But my plan for the April 1st joke is that I'm going to set up a Ceph BBS, and that you'll be able to get our roadmap from the Ceph BBS. And we'll see. But now the system is actually capable of giving you a few 80 by 25 screens in color. So I don't know how well slides will render there, but maybe we'll carry the prank a little bit forward. This is the way the Retrocampus screen looks like, and there are a few things there like you can read Wired News. Oh, there you go. You can read Hacker News from 2600, and you can select by pressing numbers which one of the stories do you want to read, and it will map you the next one. They have some logic in Retrocampus where they go and parse HTTP sites and filter down just the text for your retrocomputing use. I think the news at 300 baud is surprisingly relaxing. Oh well. Maybe we should give that. When you actually log off neatly, when you log off without hanging up, and there is a splash screen on exit, which is I don't know if I have the whole thing. I think I got tired at the end, but it's Bart Simpson saying "See you." And these are pretty impressive graphics. Remember that you have seen what contemporary PC of 1989 and 1991 respectively could do graphics-wise. This is the Commodore 64. It's a 10-year older machine, and the graphics are better than a machine made. But
It seems like playing video and speaking audio are not getting along.
All right, we'll pause the video so that we don't get that effect. Just remind me if I miss it, because a lot of these are videos, so it will start auto playing. We have 2 more. This one is the one that I'm working on right now, which is an impressively rare machine. It's another one of these briefcase-sized laptops. This was called an Atari Stacy. It's a play on Atari ST. It's effectively an Atari ST in a typewriter format. There's another LCD screen. There's an 8 megahertz 68,000 processor. So as I said, Atari machines in the 16-bit era were quite impressive in terms of power per dollar. Less impressive was the amount of software available for it. So they didn't quite make it in the business space in the US. I think I mentioned that they did get some popularity in Germany for business use. This particular machine was extremely popular with musicians because it has a MIDI sequencer built in. And these machines were used for more than 10 years after they were past, they were out of manufacturing because of this capability. Just like the comments that I made earlier about Windows, there aren't many machines that are real-time in terms of latency variance, and the Stacy could do that in the MIDI context, which is why musicians would use it to drive their music synthesizers. This is a Stacy. So there were 3 variants of the Stacy. One had 2 floppies, one had a floppy and a hard drive, and then the third variant had 4 megabytes of RAM instead of 2 or 1 as the others had. It is huge. It's even bigger than the Amstrad that I've shown you earlier, and it's actually here, so I can show you. So you get an idea of just how freaking huge this thing is. This is in remarkably nice condition for such an old machine, but it's actually quite challenging for a number of reasons. Like things are actually starting to fail. the machine is huge. It's actually lighter than the Amstrad because it has no batteries. Atari designed it so that it would have a pack of C cells to power it. But by the time they finished the design, they discovered that they needed 36 watts, and there was no way to supply 36 watts with the battery technology of the age. And so they left that bay empty, which is why actually this machine has a lot of mods, because there is plenty of space inside the case, plus there is this empty bay. So people that want to build things into a cool case can easily do it because there is space in all sort of places. There were actually some retrofits where third parties in the 90s would make battery kits, but the battery life was ridiculously low. Okay, so now we have the problem, so let's pause the video. Can you still hear me now? Is it working correctly?
Yes.
All right. So it boots amazingly quick. The Atari had its operating system in ROM, and one of the things that I plan to do is upgrade the operating system to the latest applicable version. I sourced two ROM chips with that burned in. There are some interesting things, like you will see here in the video, it says that it has support for 100 folders. Woohoo! So a couple of things. This is 18 seconds from cold start, so it boots insanely fast to a graphical environment and not to DOS. Boots way faster than a Mac or an Amiga or a PC in any environment, whether it's graphical or not. It is a 4 megabyte machine, so I presume that it's not checking the memory. Otherwise, with the chips of the age, that would take longer than that. There are some lights here on the right showing access to the disk, and some controls for LCD screens had basically contrast and brightness, so you could adjust to the room conditions and try to see a little bit more. Screens were certainly the weakest point on these machines. There are two dead lines in the LCD screen, but they are the only defect I've seen so far. And this is a 33-year-old machine, so if that's all that there is, that's good. But unfortunately, there is more. The mouse is this trackball that's built into the system physically, like it's built into the chassis. There aren't additional components out. The chassis itself has the measuring wheels to see movement of the ball. Another thing that's annoying is double clicking seems to be working erratically, but eventually I discovered what's the issue here. I haven't applied the fix yet, but I will once other fixes are in. The original Atari operating system expects double click to be on the same exact pixel to take it as double click. So as you can imagine, it's not that easy to pull off. So you quintuple click and eventually you get it. But there is a patch for the OS that fixes that. So that problem will go away. And here is a link to the patch. So that's what's gonna fix it. The views are in Windows, and there are different renditions of the windows. I like these listings, but there are icon versions of the same. This is Digital Research Gem, which was a graphical environment that competed with Windows, and it was blown out of the water by Windows 3. So nobody remembers it anymore. But until Windows 3 came out, Digital Research Gem was an option, and it existed not just for DOS. There were ports for other operating systems. For Atari, Gem default operating system essentially. This plate I was puzzled by for a while, but then it turned out that essentially it's a spring-loaded retaining device for the trackball, so the trackball doesn't move when the lid is closed. And here you can see that there is a battery LED for the battery. There is not there. And that's why the unit is so light and lighter than an Amstrad laptop, because there is no nickel cadmium brick anywhere to be seen.
Or lead acid brick.
Yes.
Gate cells would get you probably 36 watts in there for a while.
So here on the side, floppy drive, which will be interesting, and the corner hard drive on the bottom plate, which is a 20 megabyte corner, just like the one that failed on the Amstrad, but here it's working. Other connectors, there is a toggle between the internal trackball and using the external connector as a mouse. And there is one port for a joystick and one port for a mouse if you want. And we do have a we do have an Atari joystick that looks appropriately of the right age, but I haven't been able to use it yet. On the left there is a cartridge interface, which is hilarious. And apparently some of the MIDI sequencers, but the popular one attached here. So the cover of the side port is always missing in Stacy laptops because it inevitably gets lost as the band tours around. It seems like it's the most sought out part, and it's essentially impossible to find at this point. Another interesting thing, try this. Can you still hear me? Is it still working fine?
Yeah.
Yes.
Okay, so muting it seems to work. So here you can see the ports in the back. One interesting device is the port cover lifts up as a step lifting the laptop, but it doesn't latch. And this is not a defect in my unit, it's the way it is. So it slams down on the cables and it's very jarring. It doesn't break anything, but it really makes me upset when that happens. It shouldn't. I don't know what the heck they were thinking. There is a metal sort of device that pulls out, and you could catch that metal device into a board on the table or something, so that doesn't happen. It's sort of a ridiculous engineering solution, but apparently that's what they went with.
You could also just put a miniature Tootsie Roll in there,
I suppose, or I don't know, cut a cork, a piece of cork or something. So parallel port, serial port. Then there is the ST floppy port, which uses the Commodore styled connector with a lot more pins, but it's a floppy. There is a mysterious 21-pin external hard drive, which is bastardized SCSI, it turns out. An external monitor connector, which is that very dense square grid pin to the left, to the right of the SCSI. These are two MIDI connectors, and then there is the power. And the last one, I'm sure you can guess, is a reset button. So apparently I managed to figure out that this one was made in Taiwan, but the early units were made in Japan. More than 35,000 of these were shipped. But apparently not enough because it's quite a rare machine. And as you can see, it looks neat. Then it gets into the funny part of this. So never had an Atari before, so I managed to figure out this far. But I'm like, okay, I want to play a video game. So Psygnosis made some popular video games of the non-PC types, the ones that had high movement. PCs had pretty good CPU performance, but they were terrible at moving graphics fast, unlike Atari's, even the Commodore 64, the Mac, literally anything. The Amiga was great at moving graphics. PC was not. So things like Lemmings or other games with side scrollers were the domain of things like the Atari or the Amiga. So I picked up a Psygnosis game from eBay, and I'm trying to load this thing. And it has a whole megabyte of graphics and 250 kilobytes of sampled sounds, if that impresses you. And then as always, the floppy is not working. Woohoo. So, but as you can see, the screen looks different. So let's explain that first. Instead of the previous pictures of the LCD, now it's a modern monitor. I found a connector that will adapt the Atari ST out to VGA, which actually works great, as you can see here. There is an alignment problem, but the conversion is fine. And so it gives me an external monitor to work on. And here is a monitor that aligns better. The synchronization, the video synchronization is the main problem, but apparently this Acer monitor can deal with it pretty nicely. The TOS on this machine is so old that it has no version number. TOS is the operating environment, which I think means the operating system, literally.
The original system.
Okay.
As Scotty would say, no A, B, C, D, or E.
So it is definitely the original no version number. Once I do the upgrade here, this will read 2.04, I think. It's the newest version that the Stacy could support. So this one, the Stacy is newer than 1985, but the digital research gem line started in 85, and I guess this one was made in 89. And this is probably 1 point something. So there are quite a number of people that make custom decals. So I had someone cut me an Atari logo just because it looks good. So we added this. This is not in the original Stacy. Just decided that I wanted it there. And we found the joystick that I was describing before. There are actually different compatibility, different joystick formats for different Atari systems, because to remember that Atari had a very long history. So they're not all compatible. Not the software, certainly, but not even the hardware. Here, the memory looks really funny. So this is a single inline, whatever. These modules were called SIP, SIPP, and that's how the memory expansion works. So this is a Stacy 2, but there is a memory expansion bus, and we can bring it to 4. And in my archive, I only had these modules, which are good, but the chips are lined up vertically. And so that won't work because they will not fit in the space we have. So we need to find something. I needed to find something else. And I think there was something funny about these modules. Right, it's their price. $1,132 for 16 megabytes of those modules that apparently I had stashed away. So that's how expensive RAM was back then. Right now you can find these modules on eBay for maybe $10 a module. So we go back to eBay. This is the port that we were looking at. Here, behind the handle, you see this metal port. That's where the ROM chips are. So the update of the operating system will go there. And I guess the network designation for this machine, if it ever goes on a network, is Tor. Probably a reference to how bulky the thing is. And so on eBay, I found these chips that have 1 megabyte memory capacity, but chips laid down horizontally. And so they fit in the space we have. Yahoo! So that was successful. Now, the floppy drive wasn't working. So cleaning the drive from the outside didn't work. So you know what's coming in. So we opened the machine. This machine is incredibly unpleasant to open. So at some point you will see that my picture is cut out because I was sweating it so much, both figuratively and literally, that I got distracted and stopped taking pictures. That's the back plane and back side of the screen. And it's kind of terrifying to open a machine that's sort of a collector's piece, and it's so easy to break. So yeah, that's that's what gets you. So eventually I managed to get to the floppy, and it's an Epson SMD 380, like many Atari floppies are, so not too strange there. And I was able to find a substitute for it. And the bezel is this gray color. So I had to extract this bezel and install it on the new drive. The hard drive sits right below the floppy. And I'm not sure why I'm showing the connector here. Oh, I'm showing the connector because there are two connectors. Unlike the 386 that we were looking at before, this guy has connectors for another hard drive if you wanted one. So they did the right thing there. So here is the replacement, and here is the original. Wrong color, but other than that, it's an Epson SMD 380 tested by somebody else to work. So this would be easy. So spudgers solve all the problems in the world. We take the bezels out and we replace them. It's actually interesting to look at the drive without the face because there are a few details that are. It's amusing how proprietary the drives were in some of these inconsequential things like opening levers and lights. In the case of the Atari, the thing that stands out for their drives is the tendency to have these bezels that stick out, and then the coolest ones are slanted, like this button is slanted. The bezel would also be slanted. So we're done. We managed to redo this without breaking anything, which is an achievement. And we reinstall it. I'm bragging because I was literally sweating bullets. I managed not to break anything major, so I call it a win. I did break one plastic piece internally that no one will ever see, so I'll take that.
Probably had 2 screws left over.
I had what? Oh, screws left over. No, the problem was that
yeah, I'm just joking that you usually have 2 screws left over on a project like this.
Oh yes. Yes, you do. Actually, for this one, we have
smacking a little plastic tab on the inside. Well, if it's not on the outside, it doesn't affect collectible value.
I have a doggy baggie of what was left. So yes, there were a few screws, and then there is that plastic part that that is because it's so difficult to open this this damn thing, and you cannot really take one piece sequentially from another. You're basically deconstructing it in place. One of the plastic struts, like the one that you can see on here on the left, broke off as things were moving around. it's fine, I suppose. Annoying, but if I ever open it again, I can try to glue it in. It was actually surprisingly difficult to reassemble for something that has so much empty space. And mostly it's because you have no way to put your fingers and align things the way you would want. They have to fall in place and they have to be already connected. It's definitely not a machine designed with serviceability in mind. And here are some pictures of how the disassembly went. As I said, I don't have all the pictures, but effectively I managed to remove the bottom cleanly. And then I think I took some details that were interesting. Like this is the only laptop I've ever seen that has mezzanine cards. There are 2 mezzanine cards. One is power supply. I don't know what the other one is. And this big chip is this is the Motorola 68000, and there is this battery that's the CMOS battery. Because I knew how horrible it would be to open this machine, I actually sourced the battery beforehand so that there would be only one opening. And this is a rice cooker battery. Actually, I had to order it from Japan. Nobody else makes it. Nobody else uses it anymore. But I found the right variant with the right pinout. So the desoldering and resoldering was actually pretty uneventful. That part worked very well. So we got the right drive, the right battery. It's a horrible thing to open this machine, but we managed to get through it. And yeah, because the screen is really not meant to be disassembled, and all these cables are not providing you with much slack space. You're just trying to do a balancing act. Old battery, new battery. Nothing unusual here. And new battery in place. This worked perfectly. And then reassemble, putting back the mezzanines. Because the trackball is built into the case, it was actually a challenge to do all these things and make sure that the trackball movement measuring wheels are not damaged. So that was another thing that I was watching for. The hard disk drive has this mezzanine that's attached sideways to it. And it looks like it may be in a hard disk controller from it's going to the hard disk, so that's what it looks like. Right, the drive cage is a parallel mezzanine, don't ask why. But yeah, it may be that it's the hard drive controller. You wouldn't need the mezzanine if you didn't have the hard drive, so in that sense it would make some sense. And because there was a Stacy 2 floppy variant, there are the cables for a second floppy drive here, in case that was the configuration that this motherboard would ship with. The switch goes back in the case. These cables I absolutely hate. I thought that I hated the way a monitor wiring for LCD or any laptop wiring is, honestly, but this is the worst. But nothing broke. So there is so much steel in this machine, and there are Faraday cages everywhere, which is where all this weight comes from. So the rest is pretty light plastic, and as we remarked, there are no batteries. And here you can see the optometric wheels for the mouse. So the trackball turns these cylinders, and then there are wheels with actual slots cut into them that that pass in front of an LED, and that's how the movement gets measured. So not bending those wheels was the other thing that I was worried about. Okay, so that was a surprisingly messy one, it says in the comments. And here I'm complaining about how the port cover slams shut, which I've already given you the story about. So we should be good, but we're not. Why is that? All that work in the floppy drive still doesn't work. But fear not. I have an external floppy drive, which is actually also huge. So let me show you. I actually have two of them. So here it is. Even bigger than the power supply. So we try with that. And spoiler alert, it doesn't work either. It looks gorgeous, by the way, but it doesn't do anything. The cables are C64 style, and they can daisy chain. The Atari bus can concatenate devices, which is kind of cool. But it doesn't work. It lights up, but it doesn't read the floppy. And so at this point, I just go, wait a minute, what is going on here? The floppy that I just installed was tested by someone, and it's supposed to work. And the external floppy I have cleaned, and there were 50-50 odds that it would work. Nothing works. What is going on? The seeking behavior of this drive seems to be correct, but who knows? And initially, at least. And then it starts making an absolute crazy racket. So let's go one by one. First, the internal drive. So I start reading the labels, and I realize that the Atari is a mid-80s system. So websites don't really say what floppy the Stacy shipped with, but the one that I ordered as a replacement is a 720 kilobyte floppy. The Psygnosis game that I'm trying to run is on double-sided high-density disks. So it's a 1.44 floppy. I know that those floppies won't work. Then I look at the external one. The external drive, while compatible with the Stacy, is 1985 vintage. It's a 380 kilobyte single-sided double-density drive, 380K. So it's not going to read the 1.44 either, is it? But I have files, a firmware update floppy that is single-sided double density. This no, not this game. This game is not, but this. So, and the game, I'm reading the labels to figure out what to figure out the density of the floppy. Eventually, I settle on this thing, running out of Atari software. I have a version 2.06 operating system on floppy, which I could use because I have a hard drive, but I prefer to keep the thing working from ROM, so I haven't used it. This is double density, one-sided, 380, so it matches the spec. Will it blend? So we put it in the external drive. It lights up. No, it still doesn't work. But then we try on the internal, the one that we just replaced, and that does work. So we have one double-sided, single-sided, double density, single-sided drive that's working, which is 380K of storage. Not what you want for games, but it's something. Then I zeroed in on why do the external things don't really work. Here is a slight detail on what the control panel for the Atari looks like. You basically are controlling typematic and click repetition rates. There is a piece of software that's called Super Librarian, which I think is used to control MIDI, but I haven't used. I love the name though. While I'm studying the drives, I discovered that there is a book entirely about Atari ST drives out there, so I got that. And this is the current operating system, the one that we're going to upgrade. So those ROMs are coming out and are going to be replaced by new ROMs. Now, this is where I stopped because getting the software in was a problem. So now, actually, the next delivery arrived. I just didn't have the time to do it. We have the next thing, which is this cable, which is USB to serial, nothing too strange. And then we have this cable, which is serial 9 to serial 25 pin, as it's on the back of the Atari. And there is this guy in Italy that sent me one floppy disk of double-sided, the single-sided double density software to transfer files over serial, and then sent me a gigantic emulator for the DOS side of it so that I can run it on a DOS box on a Mac. And in theory, we're going to be able to bring in the software this way. This is one afternoon project, and I didn't have a free afternoon since that arrived a few months ago. So that part is yet to be done. But one way or another, the games are going to be in. The last bit, and before I end, since this is running late and it seems like a good point to stop, is the story of what did I do with the floppy drive. Oh, here is an interesting comparison of the power supply. This is not the power supply of the Commodore 64. This is the one of the Atari, the external floppy of the Atari. On the left is the power supply for an iPhone. On the right is the Atari supply for the floppy. And the iPhone power supply actually supplies way more power than the Atari one. But the Atari is the classic design with the diode bridge, while the modern power supplies, I believe, are switched. So it's not a fair comparison, but I'm making it anyway because the size difference is ridiculous.
The noise spectrum difference is inversely ridiculous.
Let's see. I thought I did. All right. While I was writing this thread, I got confused between the fact that single density doesn't really exist for PC format machines. That's a 70s thing. Everything is double density when I called it single density in writing here. And then the other one is high density. But anyway. It looks like, yeah, I didn't post the rest of the Odyssey. So the rest of the Odyssey is interesting. I opened these drives, and these drives are designed like no other floppy drive I've ever seen. There is a motor with a pulley and a rubber band that basically drives the disk platter. And I have to admit that I actually have the rubber bands to repair cassette tapes of that type. So I just opened my toolbox and I went in and replaced these. And so both of them had that. The rubber bands literally had melted. So most of the effort was cleaning them up, but one of them did not have anything on the board, so that was nice. The other one took a little bit more work. Replaced the bands, de-auxed all the connectors, still didn't work. Then I went out and looked at another thing, which is out of sheer stubbornness. I looked at somebody that repaired one of these because the components here are huge. They're all discrete components. It's fairly easy to muck with if one can figure out what's wrong. And what's wrong is, in many of them, is that the switch inside is getting rusted and it's not making connection correctly. And the switch cannot be opened, but the ball switch behind the plastic switch can be pushed in a little bit. And then when you push it in a little bit, you can pump de-aux it inside and try to clean that up. So that I did, and I cleaned up that connection. but still something else is broken. So at this point, I'm really getting stubborn about getting these to work someday. But they are double density, single-sided floppies. I mean, we have one of them working. It's enough. It's not the best investment of my time. But it could be an interesting exercise in terms of fixing something with discrete components when I get another clue of what could be wrong. And they look absolutely awesome. They are the prettiest floppy drives out there, but not very useful. I guess they will make bookshelf decoration at some point. So that's where the Atari is. Let me see what. Oh, I can show you. It's actually interesting. Atari seems to have manufactured many different variants of these drives. So this one, there are at least 3 different types, and there are different lengths, different pinouts here in the back for the power supply, and they're all SF354. So theoretically, they're all the same thing, but it's an early case of, you know how today you buy a Lenovo X1 and there are at least 24 of them when you look at the board, and the Dell XPS 13, same thing, whether it's for supply reasons or for redesigns that they do silently. This seems to have been the 1980s case of the same. This drive will work. Again, as I said, it's double density, single-sided, so can't do too much with it, but it will work. But it will not fit either one of those cases because the cases were designed for specific drive models, and some of them are longer, some of them are shorter. They changed the pinouts slightly. Interesting how much variety there is. Anyway, just a curiosity. So we are late. There is one more system that I could tell you about, but that's going to take literally another hour. So I think we probably want to stop here.
Well, at least tell us what it is.
It's sure. Actually, I'll show you the. I'll show you the beginning of the thread, and it's a Mac 2 SI. And I promised Bill that I will present this at Pearl Mongers whenever we have a venue to meet in again. And so now I'll bring in the actual system. So it's the Mac 2 SI, which is actually a pretty cool looking system and has all sort of horrors. The monitor is insanely specific. The floppy drive is, and then getting the software stack has so many things that you have to thread through that this one was a true odyssey. But it is actually now working. The thread is incomplete. There is a lot of stuff that I've put on. I tweeted this out. It is meant to be a web server, so that I like having these servers that are inside the corporate perimeter that put out some information for my project, like, I don't know, a countdown to the date we ship, or a couple of links to stats that I may generate or something like that. Historically, I've always done that. I've really done that at Red Hat. And so I was kind of harking back to that. I was like, oh, I'm going to serve this out of the 2SI. So after I solved all the problems that I'll tell you about someday, it is running a web server. I'm on System 7. I didn't cheat. It would be a lot easier to just install NetBSD on this thing, but I got it to do its thing on System 7, and I managed to get CGI working in Perl for 68K, which was another ordeal. So yeah, that's that's going to be my next Pearl Mongers talk whenever we meet.
Thanks, Federico. That was a great talk.
So the Atari and the 2SI were by far the more complicated systems to deal with. And, yeah, the 2SI I finished a couple of weeks ago. The Atari is pending. We'll see when I have a bit of time to muck around with virtual machines to load some software in it. In theory, it's ready, but in practice, you need a few hours to get something like that working, even if you're lucky. Any questions or anything else I can entertain you with?
No, thank you, Federico. It's way past my bedtime.
This was way longer than I expected, but hopefully it was interesting. For me, it was a little bit of discovery, but I hope that some of you actually use these systems. As I was saying, I was always a PC guy, so.
I had an Atari ST.
Oh, then I'll send you all the crazy questions next.
Okay.
I may need to consult you about the zip drive portability solution.
I'd say again, Bill?
I may need to consult you on the zip drive portability solution.
Oh, yes, absolutely. I actually upgraded that a couple of months ago because I originally